Here we go, 8th grade. We are starting our Chapter 9b review of factoring polynomials. Polynomials come in all sorts of lengths. We've got 1, 2, 3, 4 terms. We've got 1, 2, 3 terms with no a value, and we've got 1, 2, 3 terms with an a value. We've got 2 terms, and then we've got ones that are squared in the front and the back, ones that are squared in the front and the back, and they've got this value in the middle. Now, these are going to be our perfect square trinomials. Here, this bottom one, and we're going to show how we're going to figure those out without all this extra jazz here. So what I'm going to do is I'm going to go through different types of polynomials. So I'm just going to look at the amount of terms. So here's 4 terms. These ones are 3 terms. This one's 2 terms. And I'm going to go through my thinking process and why each set or number of terms helps me decide what options I have for solving that problem. So here we go. We're going to start with 4 terms. I like 4 terms because, like I said in class, if I told you to get in partners, I'd be acceptable with a group of 3, but a group of 4 can always be split into 2 partners. So we're going to take my 2 partners and we're going to group them. So this is where whenever we have 4 terms, we're always going to factor by grouping. Now, we should always, always, always check to see if there is a greatest common factor that I can pull out of all of the 4 numbers or variables. Often, if there's 4 terms, you cannot find a greatest common factor, but it's not impossible. So looking at these, there's nothing I can pull out. So the next thing I'm going to do is I'm going to find a greatest common factor of each set. So I've grouped them into my first set and my second set. And on my first set, they both have an x in common, but they don't have any letters in common. So I'm going to divide this set by 5. Okay, so I pulled that 5 out like it's the greatest common factor because it is. And I've got, I'm dividing by x, not by 5. I've got x plus 5. Okay, so those x's canceled and one of those, the x's in the front, canceled. And now I'm going to move on to the second one here. On the second one, I noticed that they can both be divided by 3. And I'm going to choose a positive 3. I always look at this first term, and I always make sure that that first term ends up being positive after I've taken something out. So I can take out a positive 3, and that first term stays positive. So I'm going to write positive 3, and then I'm going to actually divide them by 3. So 3x divided by 3, the 3's cancel, and I have x. 15 divided by 3, I get 5. Now, when we solve by grouping, our goal is to get one of the factors to come out and be the same. So remember how I said if we took, say, 2 times 3 plus 3 times 3, it's the same thing as saying 2 times 3 times 3. And you'd only have to say it once. So in other words, when we're factoring by grouping, we're going to take the stuff that's outside of the parentheses, and that's going to be one of our factors. And we're going to take the matching pair, and we are going to make those the other factor. And we're done. Let's do the second one. Again, we're factoring by grouping. So let's see here. I want a different color. So I'm going to separate them into 2 groups. Again, I should look and make sure nothing can divide all of them. 18, 15, 24, 20. So close to being able to do 2. Sorry about my phone there. But it didn't work for 15. Okay, so I'm going to look at just this first one here, and I'm looking to say, what can I pull out of both? Well, I can pull a 3 out of both, but that's not it. They both have x's. Whenever they both have the same variable, I'm going to look at the one with the smaller degree, and I'm going to pull that whole thing out. So I'm going to pull 3x squared. Just like we learned in our exponent unit, well, first let's take the number divided by the number. 18 divided by 3 is 6. And the x to the third divided by x to the second. Think about that as x to the third looks like this. X to the second looks like this. If I divide, I just have one positive x left. Okay? And 15 divided by 3 is 5. It's positive. And x squared divided by x squared cancels. All right, my next one. I'm looking for something that I can divide 24 and 20 by. And I see that I could divide them both by 2. However, I need the greatest common factor. If I don't have the greatest common factor, I won't end up with matching terms. And so I can go bigger than 2. I can take out a 4. Okay, and I'm going to do a positive 4. And looking at the variable, there's an x here, but there's no x value there. So the smallest value of x is not having one, so we're not going to pull out an x. So we're going to divide both of these by 4. 24 divided by 4 is 6, and then x, and 20 divided by 4 is 5. Now we got exactly what we wanted. We wanted matching terms inside of here, so I'm going to take the front stuff, 3x squared plus 4. That's my first factor, and my second factor is 6x plus 5. Remember, you can always FOIL these out to check and make sure that this is comes back to the same answer. You can check it. Unfortunately, my video will be a half an hour if I check all of them, so we're going to skip that step. All right, this one has 3 terms, and since we see a lot of different types of 3-term trinomials, I actually have 6 examples, so I'm going to rock through them really quickly. The very first thing I want to do on every single problem is I want to look and see if there's a GCF. That means, is there a number I can divide every single term in this polynomial by? And so when I look at this first one, I see 6, negative 54, and 18. Can I divide 6, negative 54, and 18 by something? I noticed 2 right away, but I can divide them all by 6. I look at the variable parts, x squared, x, and there isn't one. So definitely not any variables. So I'm going to just pull a 6 out of all of this, and I end up with x squared minus 9x plus 3. Okay? So I might be done here. Sometimes the only thing you can do is pull out a greatest common factor, but let's check, and we're going to do the method that we use when there is no a value. So when we look at this and there's no a value, I can just take my 2 middle terms and say, I want to multiply to be 3, and I want to add to be negative 9. Okay, so I'm going to try it. I'm going to list all my factors of 3. 1 times 3, and that's it. Can I take 1 and 3 and add them together to make negative 9? I can't. So normally if I couldn't do anything, I'd just say not factorable. But in this case, I was able to pull out the 6, the greatest common factor of 6, and so that's what I'll do. I'll leave it as that. It's basically kind of like simplifying it, right? The next one is in the great form of x squared plus 7x minus 18. In other words, there is no a value. We like that because then we don't have to do an extra step. So that means we're going to find 2 numbers that multiply to be negative 18 and add to be 7. So off to the side, I'm going to write negative 18. And remember, I'm kind of ignoring the negative for right now. I'm just going to say 1 times 18 makes 18, and 2 times 9, and 3 times 6, and that's it. Okay, so now I'm going to remember that it's a negative 18, and that if I know that I multiplied to be negative 18, that's telling me that I took a positive times a negative or a negative times a positive. Since I'm adding to get a positive answer, that's telling me my bigger value is going to be positive and my smaller value is going to be negative. But I need to subtract these numbers to find 7. So if I subtract 1 and 18, I do not get 7. If I subtract 2 and 9, I do get 7. Okay, so I want to make 7 with a 2 and a 9, and I have to put a negative on one of them. I need to put the negative on the 2. If I put it on the 9, it would end up with negative 7, and I want a positive 7. Okay, so if I start and I don't have an a value, I am just taking x and x, okay? Because x times x is x squared. That's how I'm starting. Then my middle terms, or my next terms, are going to be minus 2, and since 9 is positive, plus 9. I'm going to write minus 2 and plus 9. And that's all I need to do. I'm done. On the next one, again, I'm going to look. Can I pull out a GCF? Unfortunately, no, I can't. So I'm going to continue on. This time I have an a value. Whenever you have a value here in front of the x squared, you have to take this value and multiply it times this number first before you do the multiply add rule. So first I'm going to multiply 2 times 25, and instead of having 25 there, I'm going to call it 50. Okay, I'm going to find all the factors of 50. 1 times 50, 2 times 25, 3 doesn't work, 4 doesn't work, 5 times 10, and that's it. Okay, so which ones of these add to be 15? There you go, 5 and 10. So I'm going to go ahead and I'm going to write these out. Now this time, because I have this 2x squared, I can't just write x and x. I can't just write 1x and 1x because that doesn't multiply to be 2. So I'm going to make this a 4-term polynomial, and I'm going to group them and factor that way. So whenever I have a letter out front, it really extends number out front. It really extends the process, because not only do I have to multiply this first, now I have to make 4 terms instead of 3. So the first term is going to stay the same. The second term is going to be spread out between these two. So instead of writing 15x, I'm going to write it as 5x and 10x. They're both positive, so I'm writing them both as plus. And then I'm going to write my last term the same. Okay, so now what I'm going to do is I'm going to group. So I'm going to make my first group, make my second group, and just like I did before, I'm going to pull out their greatest common factor. I'm going to do this kind of quickly. The first one I see, they both have a factor of x, and that's it. So I'm going to take x out. I get 2x plus 5. On the second one, I notice that I can divide them both by 5. It's a positive 5, so I'm going to write plus 5, and I get 2x plus 5. Well, I got exactly what I wanted. Both of my second terms match, so I'm going to take my numbers outside of the parentheses and group them, and my numbers inside the parentheses and write them just once, and that is it. If I factor this out, I'm going to get this exact same thing I started with. Sorry if I FOIL it out. Okay, we got another one that has an a value. It's kind of a big a value, but that doesn't make it much harder here. Don't forget this is a negative 2, so let's apply that negative. I'm going to take 15 times negative 2, and I get negative 30. I'm going to write the factors. 1 times 30, 2 times 15, 3 times 10, 5 times 6. Which ones will make a negative 1? Well, remember I have to put a negative on one of the values, but whenever you see this negative on the value, think of it as I'm going to subtract to get that. So I'm trying to get 1 or negative 1, and by subtraction. So 1 and 30 when I subtract doesn't work. 2 and 15, nope. 3 and 10, nope. 5 and 6, when I subtract those, I do get 1. Now I want a negative 1. So if I put a positive 5 and a negative 6 together, that's going to make negative 1. So again, I'm going to spread out these terms. 15x squared plus 5x. Remember, we're adding x's to these values. Minus 6x minus 2. Group them. Don't forget to group the negative together. So on this first one, I can pull out a 5x. When I divide by 5x, I get 3x plus 1. Now notice I took 5x divided by 5x. Anything divided by itself is 1, and you do need that 1 there. It holds place value. Okay, and then on the next one, I could pull out a negative or a positive, but it's important that I keep this value, this first value, positive. So in order to keep that positive, whatever I divide by, I need to make it a negative number. So I'm going to divide by negative 2. When I do that, this first term becomes a positive 3x, divide by negative 2. And negative 2 divided by negative 2 is a positive 1. All right, so inside here they match. I'm going to take the outsides, 5x minus 2, and the matching terms, 3x plus 1. And just another set, we might as well. Okay, so again, I'm doing a lot with an a value because I think that there are the harder ones, and so I wanted to make sure you know how to do them. Ooh, before I start this one though, however, I noticed that 12, 21, and 6, or negative 21 and negative 6, could all be divided by 3. Do you see that? Now, I always want to keep my a value positive, so I'm going to make sure I divide by 3 and not negative 3. So I'm going to divide everything by 3. When I do that, I get 4x squared minus 7x minus 2. All right, now I'm going to check and see, can I still factor out this trinomial? So I'm going to ignore my GCF that I just pulled out, and I'm only looking at the stuff inside of my parentheses, and I'm going to do that problem. I'm going to change colors here so that you can see what I do after the purple. Okay, so I'm going to multiply the first times the last. I get negative 8. I'm going to list my factors. 1 times 8, 2 times 4. That's it. Okay. Can either one of those subtract to be 7? Yes. This first one. Now I want a negative 7. So the 8 needs to be negative and the 1 needs to be positive because that's what makes this a negative 7. So again, I'm still ignoring that 3 that's out front. I'm going to put it on at the end. So I'm going to spread this out, 4x squared plus x, or I could write 1x, minus 8x plus minus 2. Okay, oops, I already put one of those on, but I'm going to be grouping. Okay, so on the first one, I can divide by x. I pull the x out front, and I get 4x plus 1. On the second one, remember, I want to make this term positive, so I'm going to divide by a negative number. I'll divide by negative 2. If there is no number that they can both divide by, but it's negative, divide by negative 1, and that will change the sign. Okay, so negative 8 divided by negative 2 is positive 4. Oops, I divided by negative 2. There we go. Positive 4x, and negative 2 divided by negative 2 is positive 1. All right, on the outsides, I've got x minus 2. The matching terms, I have 4x plus 1. All right, and the last one. The last one, I'm going to tell you a hint. It's a perfect square trinomial, but let's pretend like we didn't even pay attention and we didn't even notice that the first term and the last term were both perfect squares. Let's pretend we don't even know. Okay, so we're going to go ahead and we're going to do this the same way we normally do. We're going to say what adds to be negative 14 and multiplies to be 49. Okay, so I've got 1 times 49 and 7 times 7. Which one makes 14? 7 and 7. Which one makes negative 14? Well, a negative 7 and a negative 7. Can negative 7 times negative 7 equal positive 49? Absolutely. Okay, so again, because now I could group this out. I could just do everything in the same method. It's just going to be an extra step I don't need to do. So I'm going to go ahead and write this as x minus 7 and x minus 7. Okay? Now, I noticed that that's a repeat, right? So I'm just going to write it as 1x minus 7 squared. I would not mark this wrong in the test, but I will tell you it's actually matching on the test. So you need to know that these two things are the same, right? Because it's just times itself. All right, and we haven't talked about binomials, so let's check those out. All right, when I'm factoring a binomial, remember a binomial is 2 terms, I'm just going to be first looking for a GCF and second looking to see if it's a difference of squares, okay? If it's neither one of those two things, then it's not factorable, okay? So on the first one, I'm looking, can I divide 9 and 49 by the same thing? Nope, I can't. So it is not, oops, I'm trying to find my eraser. Oh, well, I'll leave that there. Okay, it is not there's no GCF then. Okay, then the second thing is, can I take the square root of the first thing and the square root of the second thing? Now we're going to ignore this negative because it has to be negative in order for it to be a perfect, or a difference of squares. Remember, difference of squares just meant that you ended up with the same terms inside. I'm actually going to check this one so I can show you what I mean. So yes, absolutely, I can find the square root of 9, that's 3, and the square root of x squared, that's x. And then on the second one, I have the square root of 49, which is 7. So I'm going to do one group as 3x plus 7 and one group as 3x minus 7, okay? So we want them to be opposite terms because when I do check, which I'm going to do now, we want those middle terms to disappear, and if they're not opposite signs here, they won't disappear. So let's check it out. 3 times 3 is 9, x times x is x squared. 3 times negative 7 is negative 21, and 3x times negative 7 is negative 21x. 7 times 3x is positive 21x, and 7 times negative 7 is negative 49. Okay, when I simplify this, notice these two in the middle, they are the same thing, only opposite, so they cancel out, and I'm left with 9x squared minus 49. So whenever you have a difference of squares, you will always have a minus sign in the middle because a positive and a negative always multiply to be a negative. So that's one clue. Another clue is that it's a binomial. There's only two terms. And the third thing is that it has to be perfect squares on both parts. Okay, this next one does not have perfect squares on both parts. So the first thing I want to do anyways is check for a GCF. Is there a number or a letter that I could pull out of both? And in this case, I see a few things. I could divide by 2. Anything bigger than 2? Let's see, I could divide by 4. Anything bigger than 4? No. And then if I look at my x terms, I have x squared and x. The biggest x that the smallest x that I have is x. So I can pull that out. So I've got 4 that I could pull out and x that I could pull out. So I'm going to divide by 4x. So I pulled it out, so I'm going to use parentheses to show I'm multiplying by it. And I have 7x and I have 8x. Or sorry, just 8. All right. Now I'm going to still check, is this a difference of squares? Is this a perfect square? Is this a perfect square? And they're not. So I'm done. All I could do on that one is pull out a greatest common factor. All right, there are so many videos online for factoring. If you just look up factoring polynomials, if you look up factoring perfect square trinomials, factoring binomials, you can search any of those things and see whatever's the hardest thing for you to do, or you can say factoring mixed polynomials, which will kind of give you a review of everything like I just did. Good luck. Come to me early in the morning if you still need help after watching this video. Have a great day.